Hello guys and welcome back to my channel Civil Construction and Tutor, and in this video I will show you how to prepare a presentation for a structural designing and analysis of a building. So in case where we have to prepare a presentation, for example if we have to explain it to the client, or even in some cases when the building is huge, then we have to present it to the jury. So in such cases we have to submit a presentation, and in that case this video might be helpful for you. So without any further ado, let's start. So the very first page we will be discussing about the introduction, that is what we are going to present. So basically it will be structure analysis and design of residential or commercial. So that depends upon the type of structure that you can get from the report that you have prepared. So I assume that we have already prepared the structural report, structural drawings, and now we are going to prepare a presentation. So I have this building, and in addition to this I have also prepared the structural report. So I will just take the data from this two, so it will be easy to understand. So in the introduction part we'll obviously describe it, the type of project. So for example, for now it is the residential building, so I'll just simply go over here and remove this. So structure analysis and design of residential building off. So you will write the owner name over here and location, consultant, so name of the consultancy, and similarly name of the client, that will be Rajesh Khanna over here. Or even you can go with like submitted by and submitted to. So for when you write over here submitted to, write the governing body. For example, if in this case it will be Kathmandu metropolitan city, so just write over here as submitted to and write Kathmandu metropolitan city and the date. So today's date is. Now go to the second page. Now we have building dimensions. So introduction, again we'll just consider the structural report simultaneously. So I have already uploaded a video regarding how to prepare a structural report. You can see that. So in the description part I have shown over here. So introduction, number of story, I'll just copy what I have written over here with this G plus 5 with this basement. Story height, so it is 3360 for all floors. Length of building and height of building, width of building. So you can add this to value, then you will get the dimension. So it is 18.259, that is the length. Now let us consider the width as well. Let us write this in meter as well. And the width of building is 6220 plus 10425, so we get this value as 16.645 meter. And height of building, you can get this from here, 20.12. so we are not considering any stair cover like this. So this is the general introduction. Now the second in the third page we'll paste an architectural drawing. So this is also from the structural report, and if you have the elevation, then you can also paste it over here. For now I'm just using this general plan. Now building dimension, so I have already 18.259, 16 point. Building height is 20.12, and this is above the top of rigid basement. So height to width ratio, so height 20.12 divided by width 16.645, so this comes as 1.208. and in case of length to width it is simply 18 and 259, so this comes as 1.10, so that's fine. Now analytical model. So it was a different building. Okay, you can just take this one and paste it over here. If you want to add further angles, then you can do that. For now, this should be sufficient. Now structural modeling. So finite element based structural analysis software ETABS 2020 is used. So that is okay. You can write out your type of software. Three-dimensional model is done. Beam and column members are modeled as frame elements and cell elements for the slab and wall. So in case if there is any membrane type, then you have to mention that as well. For now, it is a floor, slab and wall with the cell element. So the column is a square type and beam is a rectangular section. Wall and slab is modeled as cell element that we have already explained. And dead load and live loads are applied as a UDL load on the slab, and wall loads are applied on UDL as beam on the beam. Or you can just place a table like this. I think this will be a better option to go with. So we just delete this and paste the table over here. So this can be added in this. So this will be fine. And in the next table, we'll explain about how the load is assigned to the structure. So with this, you can see here type of load, description, and how they are applied. Then we will describe about material properties. So concrete grade, again these things are already listed in the this table. So M20 for footing, M25 for column and beam. Now structural element sizes. So we have already designed this structure, we have already got the output, so we'll just put that. So from here we can see column 500 by 500. Beams, we have two types of beam, one is secondary, one is primary. So the greater size 350 by 500, it is a greater, that is main beam, so 350 by 500, and secondary beam of 230 by 350, that's fine. Slab, we have slab of 125 thick. Wall, we can get that from the design part, so we'll check over there. And thickness of waste slab is also not mentioned over here, so let us go to the design part over here. So design of shear wall, so thickness 300, so that's fine. Now the next thing, waste slab, that is this slab for the staircase. So this is the design of staircase, and here we can see thickness of waste slab as 175. Now this is done. The next slide. So it is a by default analysis values. So according to NBC, we have to provide certain stiffness modifier to the beam and wall and column. We have also mentioned this in the structural designing part over here, so you can see in the section and property modifiers. So I think it will be better to add this value. See, now we have to discuss about the analysis model method that we are adopting. So for now, we have two methods, equivalent static method and response spectrum method. So for now, we are adopting response spectrum method. Now loads adopted for analysis. So these are the standard parameters. So self weight of structural elements. So for concrete, it is 25. For masonry brick, that is 19.2. If there is any AAC wall, it is 10 kilonewton per meter cube. Lift machine load 10 kilonewton per meter square. So in our structure as well, so there is a lift, so we have assigned that load at the top slab, which is about 10 kilonewton per meter square. Floor finish, okay, we can add this in the last page over here. So loads adopted, done. So it is okay. So live load is also done. Now the next thing over here we have to mention is the earth pressure load as well. So which I have to add according to the building that I've already discussed before as well. So let me delete all this and we'll just write this as earth pressure on wall is the earthquake load. So depending upon your country, the earthquake load will be different. For example, if it is Nepal, we are using Nepal building code. If it is India, then it will be Indian standard. For I am using seismic design parameters considering NBC 1052020, and I will add these two things over here. So after the earth pressure. Now seismic design parameters. I have already computed these things over here. So this is the table that I will take and simply put over here. And not all things will be necessary because it is not sufficient, or it will be little bit vague to show all the parameters. We'll just show that is important one. And let me delete this and paste it over here. Now let's move to the next slide. Now let us compare the fundamental time period. We have to consider two methods. One is the fundamental time period using the empirical formula and the other is Rayleigh method. So as per clause 5.1, the lesser value of these two time periods shall be considered. So the time period from this is 0.594 fundamental time period. Okay, so let me delete this. So this is the amplified time period. And as we have considered structural wall building, so it will be 0.05 in both direction. And from Rayleigh method you can get this value as 0.559 and 0.794. So this is different. So adopted time period for analysis. Done with this. Now finally structural modeling. So we have discussed about this, that is how the load will be applied, how the live load will be applied, and this EQX. So 0.1 is the eccentricity that is considered, that is 10% of the width of the building. Method of analysis. So we have to mention over here response spectrum method of analysis NBC 105, and load combination considered 1.2 times of dead load plus 1.5 times of live load, as well as dead load plus lambda live load plus earthquake. So EQ either direction X and Y, and we'll be considering 0.6 and 0.3. Okay, let us keep this over here. As we have considered the response spectrum method analysis, so this is the curve that we'll be using for the analysis, and you can get this from the response spectrum function that we have defined. Now base shear check. So we have to compare the static base shear as well as base shear from response spectrum analysis, and let us see. Okay, let me use the same table from from the report, so it will be better to understand about the value. So it will give the general idea of the story range as well as value of C and K. Model analysis. So we'll add this value over here. Let us delete this one. And it is important to highlight the value that is uh, corresponding or that complies with the codal provision. So according to code, mass participation should be greater than 90%. Okay, mass participation is done, and in the mode 16, and the corresponding frequency should be less than 33 Hz. Now let us go to the next slide, and this is for the story drift check. So the displacement and drift of the building. So we have considered the displacement as well as the drift. So for x direction, we have considered for ULS as well as SLS condition. So story drift check, let us delete this, let us copy over there, and we'll just put a critical one, because it is not possible to show all the values. So in the displacement criteria for response spectrum method, we'll check for the maximum value. So design displacement from ETABS 57 in y direction. Similarly, the design drift is greater in y direction, so we'll select the y direction only. So story drift in y direction, and we'll so see, this is for EQI ULS, this is EQI SLS. Maximum story drift, maximum story drift. These are the values 0.0054, 0.004483. So for y direction, and we'll show a table to give an idea of torsional irregularity and displacement criteria. So firstly, we'll uh, give an idea, or we'll show the story displacement and drift. So simply take this table, so this is the table for the torsion as well. Check for torsion over here, story level that we have considered. Now eccentricity check, and this is also mentioned over here. So mass, center of mass and rigidity, XCM and XCR, this is the center of mass and rigidity. So now we are going to consider the irregularities in the building. So for this mass irregularity, so we have to consider this. I have already shown a video, I have already uploaded a video for this. You can check over there how to compute these things. So we can consider the torsional irregularity in the same page over here if it is possible. So mass irregularity check and torsional irregularity check. The next thing, stiffness irregularity check, and this should be checked along two direction, x and y. So firstly, let us select for x direction. Let us add another slide, so that will be for the y direction. So in both cases there is no any irregularities. For the stiffness. Now concrete frame design check. So the analysis is done. Now let us go for the design. So this is the model check. So here you can see all concrete frames passed the design check. Percentage of reinforcement. So from the design of column, we'll choose one of the most critical one and we'll show the percentage. So for now it is elevation view 2. So now let us go to this and run the analysis first. So you can see over here the reinforcement 6016106. Let's go for the reinforcement percentage. So it is 2.44%. So just take a screenshot over here and considering this value, so let us highlight this so it will be easy. And we'll paste it over here. If you want to add another elevation or plan, you can add that. So this is the elevation view and this is the plan view. And for column we have a guideline, that is the reinforcement should be between 0.8% to 4%. For beam it is different. So percentage of reinforcement is done. Now column beam capacity ratio check. So as per NBC, it should be less than 1. It should column beam capacity should be greater than 1.2 and beam column capacity will be automatically less than 1.2. And this is also shown in the report. So let us copy this and paste it over here. Now foundation design. The very first thing here will show is the base reaction. Okay, and then the description. So obviously we are going to design a wrap foundation, or also known as mat foundation. Thickness of footing. So here we have 900 mm as the wrap thickness. Shape bearing capacity according to the soil report is 150 kilonewton per meter square. And soil type is D for Kathmandu. Maximum base reaction. So these are the base reaction under column. So the maximum value is 148.13 kilonewton per meter square. And rebar detail, so we can simply add this in the same page if it is fine. And for rebar detail, let us check the maximum moment, which is 645.61. And rebar required using 20 mm bar, so we are using 20 mm bar. So the final output is 20 mm bar at 125. So this is the output. So finally, thank you. So this is the general or overall presentation that is to be prepared and presented. I hope this video helped you, and if it did help, do like and comment in the video and share with your friends. Thank you.